Hello and welcome to our lesson on exponents. This is 6.4, and today we will be specifically recognizing and representing patterns with whole number exponents and perfect squares. So I think we need to first cover a little bit of vocabulary. There's going to be some new words that you might not be familiar with. I'll go ahead and list at least the three that I think you should know. It's exponent, which an exponent is how many times a number is multiplied by itself. It's really like a shorthand way of writing repeated multiplication. So how many times a number is multiplied, that's really what an exponent does by itself. You might also have heard power. So another word here could be power. They might have heard like to the power of 2, which is the same as an exponent of 2, or raised to the power of. So power and exponent kind of mean the same thing. You also have the word base, which is the number that is being multiplied. I think it's multiplied. So it's the number being multiplied, and how many times are you going to multiply that number? And then we also have this word factor, which a factor is part of a multiplication problem. So it's one of the numbers in a multiplication equation, like 2 times 4. 2 and 4 are factors. 8 is the product. Okay, so we have exponent, base, and factor. All right, and let's go to our slides here. So in our exponents unit, I might break this up into 2 videos because exponents is a pretty big unit. It's a pretty big topic. So we're going to be writing things in exponential form. So in this equation, we see 7 times 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 7 is 5,764,801. So if you wanted to say, you have to multiply 7, let's see, one time, how many 7s are there?
Hello again, everyone.
Well, I don't want to watch the exponent video. There's 1, 2, 3, 4, 5, 6, 7. There's 8 7s. So an easier way to write that is 7 to the 8th power. And it's this little 8 at the top. It's a small raised 8, which means it's the same thing as saying 7, and a dot is also the same as saying times. Not to be confused with x's, because sometimes we're going to start seeing 7x, but that can look like 7 times 7 also. So I like using the dot, just not to confuse it with variables. So we have 1x, or 1, 7, 2 sevens, 3 sevens, 4 sevens, 5 sevens, 6 sevens, almost there, 7 sevens, and 8 sevens. Okay? These say the same thing. They both equal the same amount. 7 to the 8th power and 7 times 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 7 is the same thing. This is the exponential form. This is the expanded form. They're the same thing. All right. And so if it's to the power of 2, or if the exponent is 2, there's a word for that, and it's called being squared. So if something were to say, 5 squared, or 5 to the power of 2, that means in expanded form 5 times 5. The reason why it's squared is because a square has the same length. So a square has, if this is 5, then this is 5, and this is 5, and this is 5. And the number of squares in, if this were 5 squares, like, and this were 5 squares across, there are 25 squares. So if you had a 5 by 5 square, 5 squares down, 5 squares across, you'd have 25 squares in that square. It's also, the area is 25 square units. Since it's not labeled, if they were feet, it'd be square feet, but units squared, or feet squared, inches squared. If this were 5 feet, and this were 5 feet, then I would say it's 25 feet squared. So, like 1 square, if you were like trying to get tiles for a bathroom floor, this is 1 square. Let's say they were 1 foot by 1 foot. This is a 1 square unit. If you wanted it 2 feet by 2 feet, so this would make it 2 feet, but it's not 2 feet this way. It needs to be 2 feet this way. So now it's 2 feet across and 2 feet down. Each one is 1 square foot. We have 4 square feet on a 2 by 2 square. So 2 squared equals 4, or 2 times 2 equals 4. Let's see what that would look like if it were 3 by 3. What do you think? How many squares would be in a 3 by 3 square? If 5 by 5 had 25, 2 by 2 has 4. What about 3 by 3? So I need to fill in the other ones. That one, 3 by 3, has 9 squares. So 3 squared equals 9. 3 times 3 is 9. And 4 by 4 is 16. And these numbers are special. They are called perfect squares. They're numbers that you can take a number, multiply it by itself, and get that answer. So numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are all perfect squares because it is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So perfect squares would be 4, 9, 16, 25. If you wanted to write this in an easier way, mathematicians love saving time. 5 times 5 is 5 squared. All right, if you wanted, so now we have 3 dimensions in this picture. Instead of 5 squared, now we want another row of 5 going backwards. So let's say this were a cube, and you had 5 cubes back. So this would be 5 rows also. So you'd have 25, but 5 rows of 25. Like 25 in each first row, but then you have 5 rows back. So there would be 5 rows of 25, or 5 times 5 times 5, which would make this 5 cubed. And now we have something called volume, which is 3-dimensional object. So 5 times 5 times 5 is what? This is called being cubed. So when you do something to the second power, that's squared. So what's 5 squared? 25. What's 5 cubed? Because it makes a cube shape. If you go length, width, depth. Instead of just length and width, we're adding a third dimension. We're throwing in a cubed. So that's 5 times 5 times 5. If they were feet, it would be feet cubed because it's a volume. It's 3 dimensions. What is 5 times 5 times 5? Well, I know 5 times 5 is 25. And 5 25s, let's just count them up. Let's do 25, 25, 25, 25, and 25. So 25, 50, 75, 100, 125 is how many cubes are in a 5 by 5 by 5 model. The power is 3, or the exponent is 3. The base, the number being multiplied, is 5. Five is the factor, so we have the base, which would be the 5 in this case. N would be the exponent, which would be 3 or 2 if it's squared or cubed. And in expanded form, you just have a list of all the factors. It'd be like 7 times 7 times 7 times 7 times 7. It's really, the factors and the base are kind of the same thing. But the base doesn't show, repeated numbers. If it's the same number over and over again, you just write it one time and then say how many times to multiply it. It's just a shorthand way of writing a long multiplication problem. There is a special case here when 0 is the exponent, because you can have any number as your power. So it can be raised to any number. If you raise something to the 0 power, like let's say we took 10 to the first power, that means 10 times itself one time. So 10, it's just 10. 10 times nothing. Like, it's just 10. But 10 squared is 10 times 10, which is 100. So I'm going to say, and then 10 times 10 times 10, 10 cubed, is 1,000. So what would 10 to the fourth be? Well, it's 10 more of these thousands? Because if we'd multiplied the 100 by 10, 10 more, it's 1,000. So 10 hundreds is 1,000. 10 thousands is 10,000. So 10 times 10 times 10 times 10 is 10,000. You really will add a zero for every single power that you're going up. This is just with tens. It doesn't work this way with fives or twos. But it's easy to see with tens that 10 to the fifth, and you can even see there's 4 zeros at 10 to the fourth. There's 3 zeros, 10 to the third. There's 2 zeros, 10 to the second. There's 1 0, 10 to the first. So 10 to the fifth will have 5 zeros. 10 to the 0th power, 10 to the 0, is a special case, and that is 1. Because we're losing a 0 each time we're going down a power. We're going from 5 zeros to 4 to 3 to 2 to 1 to 0 zeros. So it equals 1. Anything to the 0 power is 1. 5 to the 0 power is 1. Negative 5 to the 0 power is 1. A million to the 0 power is 1. Anything to the 0 power is 1. Except for good old 0. 0 to the 0th power, it's debatable. It's either undefined or it's 1, but this you don't normally see often. It has to have some answer, and they're calling it, we'll say that it's undefined, that you can't do 0 to the 0 power. So UND is a way of kind of shorthand for undefined. It doesn't have a particular amount that it equals. Okay, so let me just get, for the notes, a good example of this. And I think we have a good introduction into these exponents. So let's say we were sticking with 5. I like 5. 5 squared. So 5 squared, here's 5 squared as a model. It's a 5 by 5 square. And squares always have the same amount on each side. So 5 by 5 square is, to find the area, you multiply the length times the width. They're the same number. It's 25 square units. Again, going over the vocabulary, this is called the base. This tiny number is called the exponent, or the power. And people will say raised. You might even see a little caret sometimes. If you're typing, so that you know that, because it's hard, you can't do a tiny 2 when you're typing. Sometimes people will put a little caret and say 2. That means 5 raised to the second power. Or if you can do a little 2, it would just be raised to that power. All right. You can also have negative exponents. We're going to save that for another time, but for right now, we are recognizing patterns and representing whole number exponents and in perfect squares. So you should know your perfect squares. So go ahead, write a list of your perfect squares. And perfect squares, which would be 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Even 11 times 11, they keep going. 12 times 12, 13 times 13. These are all perfect squares. So I'll put this video on Canvas with these notes. And good luck with exponents.